Welcome back, students. In our last class, we had started the new chapter, polynomials, and we have seen the introduction of polynomials. Today, we will continue that introduction and we will see the topics which we have not covered. So, today, our topic is degrees of a polynomial. This will be the first topic that we will cover today. Degrees of a polynomial. So let's begin. See, degrees of a polynomial means the highest power of variable in that polynomial. So if I say x cube plus x square plus 7x plus 5, how many variables you can see? This is the variable part, this is the variable part, this again, this is a variable part. Here the variable has a power of 3, here the variable has a power of 2, and here the variable has a power of 1. You can assume x to the power 0 here, so the power of variable is 0. So what is the highest power of the variable? The highest power of the variable is 3. So the degree of this polynomial is 3. Similarly, we have root 3x cube plus 5x square minus 3 by 4x minus 9. Here only one variable is there, that is x. X in the form of x cube, x is in the form of x square, and x is in the form of x. That is, x has power of 1 here. In this term, it has power 2. And in this term, root 3x cube, this variable has a power 3. So if you look at this polynomial, the highest power of the variable is 3. So the degree is 3. You can say it is a polynomial in x of degree 3. It is a polynomial in x of degree 3. So degree is nothing but the highest power of variable. A variable has so many powers. There may be 2 variables also, x, y, and even 3 variables or even 4 variables. They may be contained in a single term or different terms. Suppose this is one term, this is another term, and this is third term. It has a power of 3. This one 5, this one 2, and this one 3. So we are dealing with 4 different variables and they are having different powers. Here x has a power of 3, y has a power of 5, z has a power of 2, and k has a power of 3. Let's make it 3. So here the power of this variable is 3. The power of this variable is 5. Up to this, it is clearly visible to you, isn't it? But in this case, we consider these 2 variables as one variable. If suppose this is z and this is also z, then what will be the power? Then power will be 3 plus 3, a to the power m into a to the power n. The powers add up, m plus n. So we will forget that these two are different variables they are lying in the same term if two variables or more variables are there in the same term. If two or more variables are there in the same term, then their powers add up. So here the power will be 3 plus 3 equals to 6. So here variable has a power of 3, here in this case variable has a power of 5, and in this case variable has a power of 6. So highest power of variable is 6. So this is a polynomial in x of degree 6. See here it has x to the power 2. The variable has a power of 2. And there is another variable which has a power of 4. So if you forget there is x, y, anything, talk in terms of variable. Variable has a power 2 and variable has a power 4. Which is more? 4 is more. So the highest power of variable is 4 in this polynomial. So this is a polynomial of in x of degree 4. So here degree will be 4. In the first case degree is 3. In the second case degree is 4. In the third case you cannot directly say anything about the degree. Obviously you can say if you have practiced it, but when you have your exams you should not directly write that this is polynomial of degree this. So this is, if you break this and apply distributive law, it will be y cube into 1, that is y cube, and minus y cube into y4, that is y3 plus 4, 7. So this is a polynomial where y has a power of 3 in one term and then y has a power of 7 in the another term. So the variable has power of 3 in one term and the variable has a power of 7 in another term. Highest power of the variable is 7. So this is a polynomial in y of degree 7. So degree 7 in this case. In the fourth one, 3x cube plus 2x square y square plus 1. You cannot see any variable here. You see one variable here. It has a power of 3. Then you have variable here. Two different variables in the same term. In the same term there are two variables, so powers will add up. So this will give you variable to the power 4, and here variable has a power of 3. So which one is more? Power 4. 4 is greater than 3. So the highest power of variable in this case will be 4, and therefore the degree will be 4. Fifth one, x cube. Here you can again find two variables in the same term, and here you have one term with y square. Here it is x cube. Definitely cube is greater, so this is not going to be 2 is not going to be the degree. What about this case? Here you have variable x square by y. So before proceeding it like your previous case, what you had done, you had if it was x square y, then you had counted the power as 3 in this case, and then compared it with other terms and their variable powers. But since it is x square minus y, and there is a variable which has a power negative, minus 1 is a negative integer, so this algebraic expression has a term that contains a variable. This algebraic expression has a term, this term which has a variable y, which power is negative integer. So this whole algebraic expression is not even a polynomial. This is not a polynomial. As it is not a polynomial, so we cannot find degrees of polynomial for this. Hope it is clear to you. So this is about the degrees. Hope degree you understand now. If it is not clear, it will be clear to you when you start exercising and start solving more problems. Degrees of a polynomial. Now, based on the degrees, polynomials can be classified as remember this is on the basis of degrees. Linear polynomial. Linear polynomial is that which has a degree of 1. So it is going to have the form of ax plus b, c, d, anything you take. Suppose I take d. So here you will be having one constant, here you will be having a coefficient, it may be 1, and this one will be your variable. You can take any variable, but this is just a representation of the form, the style in which such polynomials will occur or show itself. So we have linear polynomial. These are the polynomials with degree 1. And for polynomials with degree 2, we call it quadratic polynomial. When polynomials has degree 3, that is the highest power of variable is 3, we call cubic polynomial. Cubic and polynomial understood. If it is 4, if the degree is 4, such polynomials we call biquadratic polynomial. Biquadratic polynomial. So basically, up to these you have to study. You can add one more. If it has degree 0, then what? If it is 1 linear, 2 quadratic, 3 cubic, 4 biquadratic. But what if its degree is even less than 1? The degree is 0. When the degree will be 0? That is highest power of x is 0. Plus 2x, no. X to the power 1 will be there. But I am talking that highest power of x is 0. So x has a power either equal to 0 or less than 0. Now if the power of x is less than 0, that means x to the power minus 1, x to the power minus 2. But negative integers as a power cannot form a polynomial. So it is a waste of talking about them. So we can only have x to the power 0. We cannot exceed this power. We cannot go below this power. So only variable will be x to the power 0 or any variable to the power 0. So it can have any coefficient such as 7. So this will give you 7. So what does it represent? It represents a constant polynomial. So every constant polynomial, suppose constant polynomial is 7 pi 11 by 7 minus 18 root 19. These all are constant polynomials. You have studied constant polynomials in your last class. Hope you remember it. So the constant polynomials are the polynomials which have degree 0, because they all have one x with them raised to the power 0. Isn't it? So if the degree is 0, it is a constant polynomial. Constant polynomial. Now, when we were studying about the constant polynomial, we had also studied about the zero polynomial. And we had studied that this constant polynomial is a polynomial that contains only one term, and that term is a constant, but that constant is not 0. For 0, we have separate naming, and that is zero polynomial. It consists of only 0. Rest other constant numbers 2, 3, minus 7, and anything else, even pi, root 7, root minus 7 by 11, anything. For other constants, we have a name constant polynomial, but for 0 we have zero polynomial. So we have constant polynomial, and this has a degree 0. What about zero polynomial? Zero polynomial, for this degree of zero polynomial is not defined. So we cannot write zero polynomial here, because for them degree is not defined. So always remember, degree for a zero polynomial is